Here we are again, Course 2 people. Lesson 89, Diagonals, Interior and Exterior Angles. So first of all, you really all know what a diagonal is, but the official definition is a line segment that passes through the polygon between two non-adjacent vertices. That means they're not next to each other, because if they were next to each other, it would just make a line. It would just do the outline. So non-adjacent. There you go, diagonal. All right, so here I drew a regular hexagon. It has 6 sides. From one vertex, I can draw 1, 2, 3 diagonals. And so I've even colored these in so you can see I've made 4 triangles. 1, 2, 3, 4. Well, so what? Well, what's the sum of the angles in a triangle? 180, right? You should know that. So then, how many triangles do I have? Well, I just said I had 4. So what's the sum of all my angles? I simply take 180 times 4, which would be that. 720 degrees in a regular hexagon. All the angles will add up to 720 degrees. Well, so what? Therefore, if I drew this beautiful circle and I inscribed a wonderful hexagon, and my teacher said, well, what's the individual angles of each of these vertices? I don't know. What am I going to do? Well, how many angles do you have? 1, 2, 3, 4, 5, 6, right? So we're going to take 6. We're going to divide that into 720. 6 can go into 7 once. Bam. You get 12. You can go in there twice. And we add that 0, right? So each interior angle of a regular hexagon would be 120. 120, 120, 120, 120, 120, 120. Whew. Okay? So this is going to come in handy because you're going to be asked to do a lot of these kinds of things. Now, those are diagonals and interior angles. What if, don't get scared, what if we're talking about exterior angles? These lines right here, these dotted lines, those would be the paths we would take if we did not turn but continued going straight. Just fans that I didn't turn, I went straight. I didn't turn, I went straight. Same thing. I did not turn like that, I went straight. All right? So all of these out here, this is the amount of the turn. So that's called an exterior angle because it's not inside, it's outside, so exterior. Now, it's also, look, if this makes a straight line, what would this be? This would be a supplementary angle, which means what? You know, come on. If this is 120 and a straight line is what? 180. Oh, my paper's going to wiggle on me. So we just simply take 180, subtract 120, and what are you going to get? You're going to get 60 degrees. So each of these exterior angles would be 60 degrees because the interior is what? 120. So I have 60 on the outside, 120 on the inside. Okay? Because it's going to make supplementary angles. This would be 60 right here. This would be 120. This would be 120. This would be 60. Get it? It's not hard. You just have to think about it for a minute. Right? So we would have 120 and 60. Again, we would have 120 and 60. All right, they're all supplementary angles. Easy peasy, lemon squeezy. This is the entire lesson. So I think the secret word should be easy, because I don't think it's very difficult. So that's my secret word, SW. Secret word, easy. So you are going to copy this down with me as your practice set. All right? So first of all, try to make as close to a regular pentagon as you can. That means all sides are about the same length. This is not exact, but good enough. All right? As long as you know that this is supposed to be a regular pentagon, which means all sides are equal, which means all angles are equal. All right, so how many diagonals can we draw from one vertex? Well, here, without my ruler, it's going to be a weird looking line, but let's go. We can go from here, oops, come on, little pen, from here to there. Oh, that was a pretty good line. And from here to there. Can I go from here to, no. So how many could I draw? I could only draw 2. That's right. So 2 would be the answer. You could only draw 2. Well, how many triangles are there now? Well, there's 1, 2, 3. See, this is like kindergarten work. 3 triangles. So what is the sum of the measure of the 5 interior angles of a pentagon, and how do you know? How do we know again? Each triangle is 180 degrees, right? We know that from a long time ago. So what are we going to do? We're going to take 180 times 3. So the measures of all of them are 540 degrees. How do we know? Each triangle equals 180 degrees. Write that down. I want to see all your little work. I want to see this, I want to see that. All right, now, what is the measure of each interior angle? Oh no! I want to know this one. 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 And I want to know this one. Well, what do I know? I know that all 5 are 540. So I'm going to divide 540 by how many angles? 5. All right, so let's do that. 5 goes into 540. Well, it goes in there once. Get a 5. We'll do 0 and 8. So each interior angle is 108 degrees. Why? Because we have 5 interior angles and we know the total is 540 degrees. So each angle is 180. Well, okay, if I know that, I know my exterior angles. No, I really do. Because, remember, exterior angles would be as if we just went straight, right? So this angle right there is 108, right? Yes, it is. So to make it 180, what does this angle have to be? Well, I'm going to take 180 and I'm going to subtract 108. And I will get, let's see, 7, you got a 2, you got a 72. So each exterior angle is 72 degrees because why? The interior and the exterior must equal 180. So what is the sum of an interior and one exterior? Well, I just told you, didn't I? 108 plus 72 would be 180 degrees. Bammo. See? Pretty easy, right? Now, the homework that I want you to do. Oh, I didn't get that ready beforehand. So you know what? I'm going to add that as an annotation at the end. So you are going to have to look at the screen in a little while and copy down all of the problems I'm going to write. I'm going to talk a little while so that I have a long little video in which to put the annotations. So hang on, here it is.